A person is riding a zip line between two towers that are 185 meters apart. When they reach the end of the zip line, they are 20 meters lower than when they started. What is the angle of their displacement below the horizontal? Okay, so what information are we given here? A person is riding a zip line, and they have some displacement between the start and end points. Let's draw a dot for the starting point. The two towers are 185 meters apart, so let's draw a horizontal line labeled 185 meters. It also says the end point is 20 meters lower than the starting point, so let's draw a vertical line labeled 20 meters. Here's a second dot for the end point of the zip line. Now let's draw a displacement vector from the start point to the end point. We could have also labeled the distances like this. Since this question is talking about a physical scenario and it didn't mention anything about x and y axes, we're only dealing with positive, horizontal, and vertical distances. We can draw this picture however we want. We could even flip it so the displacement is going right to left, as long as the endpoint is 185 meters from the start in the horizontal direction and 20 meters down in the vertical direction. If you want, you could also draw the towers and the ground, but we'll just use this picture. So the question is asking us to find the angle of the displacement below the horizontal, which means the angle between the vector and a horizontal line. In the picture, that's this angle. For the given information, it probably makes more sense to just reference the labels in the picture instead of writing out the information in words. But we could write that we're trying to find theta, which is the angle. So how would we find theta? Well, from our picture, we can see the displacement and the two distances form a right triangle. So we can just use the inverse tangent function to find theta. The opposite side from the angle is 20 meters, and the adjacent side is 185 meters. If we plug that in, we find that theta equals 6.2 degrees. So we'd say the displacement is 6.2 degrees below the horizontal. And that's it. For problems like this, where we're given some distances or lengths, we just have to draw what the physical scenario might look like and use geometry to find what we're looking for. If you want, you could include the x and y axes and say that the x component of the displacement is 185 meters and the y component is 20 meters, but it's not always necessary. In this case, we're just dealing with positive distances and angles, so using geometry is enough to answer this question.